AI and optimization under constraint. Basically, what I will be talking about, the what are the challenges we face when we try to these type of optimization, machine learning and data science stuff in then public infrastructure or public domain. I will be try to be generic, but I will be taking most of the examples, like all the examples from railways. So this is the part which I will be talking about. Little bit introduction. What my idea is, how the human impact come into play, because Indian Railway is a organization which is driven by Government of India. So when we are doing some kind of optimization or some kind of data science, so it has to take into account how it will be going to impact the public of the country. So doing optimization become or any, it cannot be simply from a commercial perspective. Then implementation is again a phase wise due to its employee spending across 78 divisions, 16 zones. So again, implementation becomes a challenge. Then we will talk about how it becomes important in this type of large organization to understand its processes in a deep manner, how each process interacts with each other. Then we like sometimes what has happened in what I have seen in most of the system, their application will have been developed for the user. They are capturing only some transactional data. So, but when we see they are AI ready, so most some of the data part is missing. So I will be talking about little bit about that. Then I will be talking about how the hybrid combination of AI and optimization can be harnessed to solve some of the problems which cannot be directly captured or cannot be learned because of the widespread or geographical nature or some local heuristics which are happening at due to size. So as I have already told, public, see, I will be not be talking about more algorithm most of the time. I will be mostly talking about what are the constraints which we face when we are dealing in this uh, public infrastructure like of thing, like human, operating, political and data driven. When we try to optimize or apply data science in these type of systems, because it becomes difficult for us to make happy all the people in the system, public, the users, then the central people who want commercial impact, the users which want ease, and the public which want the minimal effort or change their system. Like if I talk about a problem, if we introduce a dynamic pricing thing into Indian Railways, then we have to take into account how it will be going to impact the ticketing system in the to the public, or in freight also how will be it will going to impact the suppliers. So these type of thing we have to take into account. Then if we talk about freight also, again there is some political issues, unions issues when we are trying to solve these kinds of problem in this kind of public infrastructure. So so that is why the tagline of this video I have kept is AI is not about replacing decisions. Here we have to make them understand it is not replacing them, it is strengthening and will be beneficial for them under keeping taking in into account their all problems. So next point is human-centric design, sensitive decision constraints. When we are designing these systems, like if I am designing a system for fueling optimization in Indian Railway, so here I don't not only have to keep into account whether my crew should be maximally utilized, but I have to take into account how much rest I am giving to him, whether I am giving him proper duties or not, because it is not the fact that they will come into picture, their unions will come into picture. So that human impact has to be kept into account when we are designing system for these type of problems. I will talk in detail about this problem. So we here sometimes we had to leave the optimal and move to the adoptable. We give more and more rest to them. So at least they start following those systems, and once things come into system, then they can be made more and more optimal. In this human centric thing only, there is one type of problem we face is ki the users which currently making these links, which are working on them, what feeling or what insecurity they have is कि once these type of system will come into picture, we will be replaced, our jobs will be replaced. So what we have to do is to we have to design system such that ki their contribution, they don't feel that their contribution becomes zero or nil, they also come into picture. So while there, and we have to explain them that it is an assistant to them, we sometimes provide user controls that they can input and they can control the decision. Sometimes it happens ki when we give too many controls, optimization goes zero. There is no optimization. But still, we take into account ki at least the things which were working manually now has become digitized, and now we have the data to study ki if our engines were used, what would have happened, and now what you are doing is is like we have something to compare. So what we do is ki sometimes we make decision support systems, we give them control. There is an engine, but it is giving nothing. But still we get some data to compare, and then we go back to the system and ask them, see, this is the difference. So this is the phase-wise manner we gain the trust of the users, and then we start more and more optimization or AI/ML thing to them. We start changing algorithm beneath, so that it is a gradual change of not a sudden change for them. So one such example was which I was giving is a crew link optimization. What happens in crew link optimization? Indian Railway is divided in this way, like there are division, there are zones, then there are divisions, and there are lobbies. So there are around 16 zones in Indian Railway. Then there are around 72 divisions, and there are lobbies there. So what we did in this problem, ki the main target of solving this problem to give a global optimal solution at one go. Ki there should be the crew, the train segment, everything should be divided in one go. We get an optimized crew plan for the IR in one shot. But that will not be acceptable due to those political and union issues. So what we have given till now, we have started doing a lobby level optimization. Currently, we give a control to that lobby operator that he can enter data into the system. Then that data will come into our system, and then we will optimize. We are also giving him some parameters so that he can also put in, and he doesn't feel out of the system. And then we give an optimization tool. And now we are gradually shifting it from taking control from it to the complete automation process. So as highlighted earlier, it was used to take to make that link around from 15 to 20 days and even a month for a single lobby. But now at least that process has become efficient. That link gets generated within minutes. And secondly, while doing this queue long optimization, apart from keeping the main constraint which anyone will keep, like crew productivity, night hours, we have also focused the quality of life of that queue doesn't get hampered. He should get maximized rest. His rest is also maximized, at least at the headquarters. Like we IT people or anyone gets 2 holidays in a week. So that type of things has been kept into the optimization yeah, objective function, so that that thing is enhanced, so that he doesn't feel ki I am being overworked by the system.
There's a question in the chat, Ayush, from Sri
Uh,
Prakash Ramadas, um, asking how do you decide at what level to optimize? How did you decide on that?
See, how we decide ki up to what level to optimize is like based on the discussion from the business user. We start with ki we will do a full optimization. But when we present the solution to the user, they then based on that discussion we come to know ki up to this level it will be acceptable. So that way, based on discussion with business, based on discussion with the stakeholders, we come to know ki till this point, at this level, the maturity of the user or is this. So we should optimize to till this level, and later on we can improve it. Like sometimes what we do is we give it as a report. We don't ask him, we give a full complete solution, give it as a report. And based on it, feedback, we keep on improving it. And then we start integrated it with the other system, which will be of actual use. So one way of doing it this.
Thank you. I hope that answers the question, Sri Prakash. Otherwise, feel free to ask again. I see two people asking similar question. Mahesh is asking, is it solved as a multi-objective problem?
I
Since
didn't get
you're
you.
is this problem that you're talking about, is it solved as a multi-objective problem? Because he saw that you had multiple objectives in the previous slide. Are you
Yes,
solving
yes.
this as a multi-objective problem, or could you describe the optimization process a little bit?
Yes, we solve multiple objective problems, but in this case, we have tried to convert all this objective into a one single number, which we have derived from all these objectives, and it becomes a single objective problem.
All right, I think maybe we can talk about that later as well because that sounds
Yes.
yeah.
Yeah, we can talk about in detail how we have solved it. So one another problem which we solved is of train seat quota optimization. So I can give you a background of it. What happens in Indian Railway? There is a reservation system takes place. So when a train run from one origin to a destination, there are multiple destinations in between. So a particular seat has to be divided between these destinations. So which seat to be divided between? If I start from O1, so one seat is available from O1 to D1, then from D1 to D2, and from D2 to D3. But this seat is divided into four legs. So how I divide my seat between legs in which such that my revenue become maximized, that was the problem we started with. But what happened with us is when we talked with the domain, we came to know we cannot go totally with the revenue maximization problem. Case is this because what we find when we study the data, if we want to maximize revenue, it will break the seat as much as possible. And what will happen that people who want to travel longer distance will not get the seat, and it will be unfair. So at that point, what we did, we divided our problem into three parts. We give three models of optimization there. Fairness, in which we are preferring both a longer distance demand as a shorter distance demand, and two separate models also, because in Indian Railway, what happens, there are some trains which run for shorter distance. So there they can prefer a shorter distance optimization problem model, and some trains which run for longer distance. So they can prefer a longer distance optimization model. So this way we divided this problem, and now this is being used by IR, like more than 4 to 5,000 trains metrics has been prepared from this model till now. So this is our one of the productionized model. Now I will cover understanding system and organization context. So sometimes what happens when we are solving problems and we need to solve it at global level. So if I talk about a problem which I was solving personally was empty rake or rail car allocation for freight business. So what happens? A freight train start from a certain point A, and from Delhi it has to go to Chennai, but it has to do multiple loading and unloading in between to reach that point. So how to decide that path so that this empty run minimize? It seems to a simple problem, but when you will go into the analogy how it works, so it becomes big, because there are multiple operations which are happening for loading unloading, train running. So each and everything has to be taken in account when we designing an optimization system for this problem. So what we did, what happened? So what we did, we divided it into a process flow, ki how where this empty rake optimization come into picture, and what processes take before that and what processes take after that. So as you can see through this flow, ki optimization empty rake optimization, before allocation of rake is decided, we need to know the demand. So require a actual demand or a forecasted demand. So first that model needs to be built. Then there might be certain empty rail cars which might be at different conditions. They might be running at loaded, they might be under examination. So when they will come out, when would they be available? So for that we need another model, that is rake release. So we need to build that. So after that we can start empty rake optimization. So here, hello.
I'm hearing you. You're very good. I hear you perfectly. There's a discussion happening in the chat, but we can talk about it at the end because I think it will be a long discussion.
Somehow I think there is problem is sharing. Is my screen visible?
Yes, we see freight business framework operational short term.
Yeah. So for to solving empty rake optimization, we have to solve these two problems first. So it makes important to, when we are solving a problem in a large system, to understand where your problem lies, so that you can plan properly ki whether some models or some AI model, some optimization model is required prior for solving that problem. Otherwise, sometimes what happens, you solve that problem keeping some assumptions, keep but you will not, we do not able to get it deployed because the input and output where to give is missing. So this, uh, as well as it also help us to define ki who will be the user, because sometimes not defining the user is again a problem. And usage too. This empty rake optimization can be of multiple uses. Like first is we are minimizing it. We are giving a plan. In this way, this empty rain will happen. Secondly, what we can do, we have now created a plan for it. Now we required a crew, a loco. So again, it will be an important thing. So this also help us to define the importance of that problem. Uh, the second point which this understanding help us to help us to map decision timing and information flow, ki how the information will flow in the system when we are putting this optimization into context. Then capture rules, this is of utmost important because and in context of Indian Railway it become more important because there are some local rules which are followed at division and zonal level, some there are global rules which have followed at the central level. So some rules you will guide find in the form of written, but some rules are not written and needs to be defined during modeling also. Some they are informal rules which you cannot define, but they need to be learned. Another point, data quality. Like in one of our problem, we found out key it was allocation of the rake for examination, but how we will define the capacity of that examination point. So defining for defining capacity, you need that master data. So at the end, we came to know that master data was missing. So that is of another importance. This data capture also help us to how cohesive are different application, because if you are integrating one optimization solution, data science solution into one application, then how it will be consumed by other applications. So that data flow and system constraint also help us to capture. At last, I would say कि when you are developing a technology, we should check how fit or how mature our user is to adopting this technology. And now I will talk about little bit about one of my problem which I am working on, in which we are comparing using machine learning as well as some of the optimization for combining the two things. And here it is certainly what we are trying to capture these informal rules into the system using machine learning. So it is a two-part problem. So like I talked about empty flow optimization. So empty flow optimization, because for empty flow optimization, you have to route it to, after every unloading, you have to route it to a next loading point, which is optimal. But how will you do that? So for doing this, we can go for a static optimization, right? We can take travel time, some priorities, some path constraint into the picture, and we can design it. But what happens? Sometimes that optimization give a good solution, which is at a phase look good for us, but it disturbs the balance of the system, which is kept intact by the manual people, which when they do manually, like they already know कि a particular rail car will come to me, I will send it to a particular location X, and if a particular rail car Y come to me, I will send it to a particular location A, because they want to keep a balance in the system. So that part, right now we are trying कि we should learn that through machine learning from the data we have, and then we should try to give some weightage to this machine learning model and some other weightage to a optimization model, and then give solution to the user, so that we cannot go, like when we give a solution to the user in opposite, but in like a poles apart direction. Because when we solve this problem with optimization, there were certain decision which does not match completely with the field, what is happening at the field. So this is one of the thing which I say ki how AI can help the optimization model to become more acceptable and more usable. So at the end, I would like to say ki if AI and optimization used together in a like a thinkable or a more grounded manner, so they can be of great success. But in this, we need to keep a check what our system has and what our system wants from us. Otherwise, the solution most of the time dies in our laptops or machines, and they don't see the light. So, so at the end, what I've written, optimization public information is not a technical exercise. It should not be. It should be. We should be empathetic toward the user, toward the people who it will be impacting, and then we should build those systems so that the power can be harnessed in the most actual way we want.
Thank you, Ayush. There's multiple questions in the chat that um, I think we can go through if you are okay with that.
Yeah, yeah, we can.
I think the first there was a discussion about the question that Mahesh and Siva asked about the multiple objectives and whether you
Hmm.
could describe the optimization process. You said that you uh, put all of the different objectives together in a single objective.
Yeah.
And there was a question whether this is happening in an aggregated manner. And by aggregating, you will probably have some trade-offs also that make it impossible possibly to get to certain parts of the fitness landscape, and whether you have seen that or whether you think that that was actually a problem or that maybe some whether the different stakeholders were okay with this trade-off.
Uh, so Leon, first of all, I would like answer this key. They are trade-offs. These type of problems are the first, like these are the initial first kind of we are solving it. So there is always a scope of improvement in all these problems. So all the suggestions are coming are well taken. They can be implemented, can be checked, key what we have done and how they can be improved. So right now, what I can tell you ki what we have done. See what if you look at it, we have written around five objectives here. So in this, when you will see, most of the objectives are in terms of number of hours. So what we have done, like the modeler has done in this, they have converted all these into of a total link time objective and covered that and tried to minimize that. So that is why he is able to give take an aggregate approach there. But it is absolutely possible that this can be improved. Multiple objective functions can be used. We can give more weightage to one part and less weightage to others. Like this minimize pair duty hours, yeah, that we can improve. Like we can penalize it or we can learn it. Spare here means is ki we send a driver from A to B and it comes back as a passenger in another train. So currently we have managed to somehow aggregate it in the same function, but it can be treated separately also. So that is okay. So there are multiple ways to undo this problem. So
Yeah. So it
I'm
sounds
saying
like
it is not. I'm not saying ki there is no scope of improvement here. There
yeah,
is a lot
you're
of scope.
because yeah, we also talked like you start like this is one of it's a huge railway network and
Yes,
you're just beginning to touch the surface. Like 6 years ago, you
yes.
started with all the you told me I can imagine. Um,
Mm-hmm.
Yeah, I think Meinhof has some very interesting thoughts about this. So I will send you, Ayush, the points that he's raised about this, so that you might contact him because he's has some ideas about this. Um,
Okay.
I think that then Sri Prakash made a very interesting statement about the political part of the of Indian Railways, how this is actually impacting it. And then Goran at the end is also asking, um, this political influence, how have you been able to actually navigate this? Are there any tips you have? What do you think are the biggest soft skills that are important to this? Do you want to comment on that?
Uh, Soft skill you are ki how to convince people.
I mean, and I'm not really sure. Maybe either Sri Prakash or Goran, you can raise your voice and ask Ayush the more direct question if you feel like.
Hello. So
Hello.
yeah, I understand that Ayush has a very difficult problem to solve. Means it is. Um, I think it requires a lot of patience and humility. It, it's it's not something for the faint-hearted at all. And just dealing with so many people, so many voices, and trying to please them all. We call it optimization, but it's very possible that you're not satisfying anybody at all. That's all I have to
Yeah,
say.
Very briefly
but
from my side of the question. So, if you can share some tips, what worked for you when negotiating with stakeholders who want different things, what didn't work? I know it's a difficult question, but any tips appreciated. Thank
the things which work for us till now is ki uh, we at the end we don't try to sell them optimization. We try to sell them product which is usable. Yeah. So we don't say ki at the end it is not ki currently some of the things which are like when you design an optimization or decision support system, it doesn't exist in most of the cases. There is nothing they are doing for that process. So even if optimization is not there or that AI ML thing is not commercially not giving any output, but at least something come into the picture. That process become digitized at least. So at the end, our goal is ki at least what we have done should get implemented, and then once it gets implemented, then later on also we can do more improvement in the optimization because our main goal in initial stages to bring the user to the digitized stage. Then we can talk about him or explain about him to the optimization thing. At first instance, if I will say ki, if it is a crew link optimization and I am saving, you were taking 14 crews and I am making 7 crews, then he will be like suddenly like you are telling me you are wrong. So he will become anxious. So these type of things we don't try to sell him. We try to tell him ki it should be comparable to what he is doing, what he is getting, and then slowly we can bring him to other things like based on comparisons with his solution and our solution, taking in his so that he start trusting us. Like it takes time. Like if one optimization engine, if we are building, it takes 1 year, 2 years to get completely implemented. And sometimes we go small, like we start with a division or a zone, and then we proliferate it to complete IR. In one go, if we target the complete IR, then again it will.
I think that answers your question, no, Goran?
Yeah, thanks. It could be a longer discussion, I'm sure.
And we also have a question from Naman Joshi. If you would like to ask it yourself, you can unmute yourself. Or in the meantime, the question is he asks if the prediction of demand in this case is then dangerous.
Uh, in which case? Like there were multiple cases.
Is Naman still here in the call? Hmm. Maybe he'll come back. Until then, Shantanu also has another question. He has a specific question from the slide where you talk about the hybrid AI optimization approaches. So he asks, are you trying to use AI to develop or discover the constraints in the first place?
Yeah, it is like we are trying to reduce the decision variables only into the system. We are restricting it key. We don't give a solution which is we are trying to like reduce our search space using AI or machine learning. Like in the first phase we only give it to give a solution which is possible or which has been taken in past. So we are finding optimal among them, and then we can go for our complete optimization if this much get accepted, because at least we know this thing has been accepted by him or done by him only in the past. So that way we are at least sure that what we are giving is completely acceptable on the feed. We are doing this because in when we are doing the problem which he has asked, like empty rake allocation, certain number of constraints. Routes are defined in this way कि there should be crew, loco should be present on those paths. And if we choose a completely new location where we are sending an empty, we don't know right now when we are doing empty flake allocation problem in isolation,
Mm.
whether the rake or crew or loco will be there. So either we should take those things into account, but the problem becomes too heavy. And if we are not taking them, then we need to be sure what we are giving as an output is acceptable on the field. That all other constraint will be operational constraints should be validated. So for getting those operational constraints into picture, we are using machine learning.
Mm-hmm. Thank you. Um,
I think there's still a question by Sri Prakash again, and I also had a question that I can ask afterwards. So, so Sri Prakash, do you want to ask it again? You can mute maybe.
Yeah, I wanted to understand how much infrastructure is there for this optimization. How do you, I mean, this physical, this probably cloud. So how is it distributed, and how many people get to see these solutions that you're proposing? Thank you.
See, it depends. The infrastructure is not an issue for like technical, like IT infrastructure is not an issue for IR right now. So we have enough. Like we have private cloud too. We are having access to public cloud too. So in this way, we are like at a good place to do all this kind of stuff. And how many people depend ki what problem you are solving. So when we are solving a cooling optimization problem, so there are 72 divisions. So in these divisions, there are around so there are fixed 72 users which will be designing for all their lobbies, solution for all their lobbies. So when you are designing cooling optimization, you are connecting with all these 72. Sometimes there are two, three people in a single division. So that way, that planning problem. Similarly, if you solve log pooling, similar kind of share you will get. When we are solving this quota optimization, we have CPTMs or passenger managers, which will be creating these. So then again present in the division. So again there will be 72 divisions. So based on that share, you get number of users. Uh, Public don't get to see the solution, but they get impacted by these solutions because they are internal operations which many people don't know in the system.
So let me ask a follow-up question. So there would be overrides by the people of your solution, right?
Right.
Is there a review mechanism, or does anybody care about how many times an optimal solution that the system proposes is overridden? Do you measure these things? I'm just asking.
Yeah, that we are capturing. Like in Crewlink only, I can give you again an example of Crewlink. What we do, like on monthly basis or like quarterly basis, we do the analysis. Ki this much Crewlinks were prepared by our system, and what were the actual usage on those. Like how many of them were actually used, and then we compare the savings. Ki if they have used it from our system, and if they have used it, what they have used manually, what is the difference. And then we do aggregation and division and zonal levels, and those are presented and checked ki this much deviation is there, so that we can push ki these systems are more and more used.
I think there's no other. Someone wants to make. I will right say that I also want to comment. I think what is for me incredible is that like where we work in Dots and Lines, but also I think many people also during my research time, we received quite understandable problems. But I can imagine that starting this, just like the hugeness of the problem and the complexity and all the different areas where you can go into, it must be very exciting, very difficult, very overwhelming. And I think that this discussion about how, like, um, to start just with the first technologization and then later only looking at optimization, it is a very different road on the whole optimization path, which I think is very interesting to hear. I've not heard it so often like that. I want to say that. I think Chung Yao, you also wanted to say something. Do you want to unmute yourself or shall I read it out?
Can you hear me?
Yes.
Okay. It's basically in the comments. So yeah, it's just rambling about something that I kind of see a connection between the earlier comment on politics and the multi-objective optimization. And if anyone is interested, feel free to read my comment. Yeah, that's all.
So I think it's actually it's very interesting. Yeah, if you think, it sounds like you even want to solve politics through mathematics. Would be amazing. And there was one. Yeah, there's
Politics
one
is
more.
not like politics. You like no, you don't cannot describe. So mathematical definition right now, so we don't have like these things are not said by anyone. This is where known thing. People just know ki this, if we do this, this will happen. So
Yeah, I think I will read his comment because I think it's very cool. If they do multiple objective techniques to solve the problem, the Pareto front might provide some solution or a set of solution that can be brought to the different political parties involving in this. So, yeah,
I think then too we should instead of politics we should see ki how public impact can be come into these models. Then the politics part will solve itself. It's not
but
about politics, it's about the public because they are getting impacted. So if we answer their queries, if we are able to satisfy them, then there will be no politics at all.
but what I think is interesting is that this is a very practical way of thinking. Oftentimes, the public would, for example, benefit from a certain thing, but they want something else, even though some one thing would work best. And I think that even working with companies, you might have different stakeholders, but also different stakeholders have different political power. I mean, the CEO has a different uh, uh, weight. Even though maybe the CEO wants one thing, you know that thing they want might actually negatively impact their business or all of these things. Like what is the best question? That I think it's always a big question, and I think there's a lot of
Yeah, this is present everywhere, not in India alone.
yeah.
The convincing something is
All right. I think people are making nice jokes in the chat. I think we can start wrapping up and go to the to share our slides again to talk about what is next. Thank you so much, Ayush. Very interesting.